An operating systems question based on process synchronization. They have given this pseudocode that is used to perform the synchronization, in which S is a semaphore initialized to 5. So it is a counting semaphore because its initial value is 5. In line number 2, that is here it is being initialized with value 5. And counter is a shared variable initialized to 0 in line 1. So this counter, it's a shared variable, which means for all the processes the same value of counter would be used. They will not have the separate variables named counter for each of them. Assume that the increment operation in line 7 is not atomic. So this is what they're talking about, and this operation is definitely not atomic because it is said that counter is a shared variable. So if it is incremented by one process, then it will be incremented for all of them. That is what they mean by operation being not atomic and the variable being shared. So now this pseudocode is given based on which the synchronization will take place. And at the end, what they are saying, if 5 threads are executing this function concurrently, then which of the following program behaviors can be possible? So it is an MSQ type of question. So let's first understand the synchronization they have used. Initially, the value of this shared variable counter is 0. Then the semaphore is initialized to 5. And here from this line 3 onwards, here is where the parop function starts, and this function is executed by 5 threads, or we can say 5 processes simultaneously. So what does this function do? It is using 2 weights on the semaphore. Initial S value is 5. So whenever a process wants to enter the critical section, it will first perform 2 weight operations, which means it will decrement the variable S, semaphore S value by 2. And after that, it will enter the critical section that has not specifically been mentioned. And after that, when it is done from there, it will increment the value of this shared variable counter by 1, and before leaving it will once again perform 2 signal operations to restore the value of the semaphore S. So this is how the synchronization works. Let us check out what are the given options. The value of counter is 5 after all the threads successfully complete the execution of parop. Now this parop is this particular function that's being executed by the 5 processes who are trying to execute concurrently. So is it possible for the value of this counter to be 5 at the end? It is possible if all of them execute sequentially, one after the another. Let us say the 5 processes are A, B, C, D and E. So first this A will execute, initial value of counter was 0, so this A will make it 1, then it will complete its execution and come out. Then B will start executing this parop function, so it will increment the counter variable value to 2, then 3, 4 and 5 at the end. So yes, it is possible that at the end value of the counter variable would be 5. It's possible if sequential execution is performed. Now the second one is saying that its value can be 1 after the execution. Now if they execute sequentially, then it is definitely not possible. So let us see if it is possible if there is some interleaving between them. Let us say the first process A, it starts executing this parop function. It completes its line 5, line 6, but when it is at this line 7, at that time what happens is it has to increment the counter variable, and we know that this increment takes place in 3 steps because we need to use the register for this purpose. So first it will read the counter value, then that value would be incremented and stored in the register, and after that it will be written back to the, it will read back from that memory, from that register. So these are the 3 steps in which increment actually takes place. But let us say when this process A was on this line 7, and while it was performing this increment operation, the counter plus plus operation, at that time itself another process, let us say this process B came into picture, and this process A got it went into the waiting state, that it got preempted there. It would go into waiting state. It would, let us say this was line 1, 2 and 3. It had incremented the value in the register, but this return back operation was left. So when it again comes back from its preemption, then it will resume here at line number 3 of this operation. So let us say in the meantime, until now the counter value is 0 itself and A is in the preempted state. Let us say in this meantime, B, C, D and E, all of them execute sequentially. So what they will do, they will increment the counter as 1, 2, 3 and 4. So now final value of counter is 4. But now when all of them are done, then this processor comes back and it resumes here at its line number 3 of incrementation step. So now only return back was left. The value was already changed from 0 to 1, because when it read the counter value it was 0, so it changed it to 1, and just what was left was it had to write back that 1, which means now after resumption what it will do, it will change the counter value to 1 from 4. E has made it 4, but this A will once again make it back to 1 and complete its execution. So at the end, as we saw, it is possible for the counter value to be 1. Now option C is saying the value 0. 0 is definitely not possible, as you can visualize that in whichever way do we execute the processes parallelly, sequentially, with interleaving, with preemption, it is never possible to get the value as 0, because whichever process executes last, it will definitely increment it from its previous value. So 0 is not possible. And the last one is saying there is a deadlock involving all the threads. Now in this scenario, is the deadlock possible? Let us say we have every process performing 2 wait operations. So if it so happens that because we have the initial value of S as 5 and we have 5 processes as well, then what if all the processes start concurrently, all of them reach up to this line 5? That means all of them perform 1 wait operation on this semaphore. So when all the 5 of them have completed their line number 5, at that time the value of S would have become 0. After that, no process can move on to line number 6. Means all of them are stuck at this particular point. They are waiting for the semaphore, but its value is 0. So this is where a deadlock will take place. None of them can move ahead, and none of them can even release their held resources. That is, none of them can perform a signal operation after this 1 wait. So if such a thing happens, then it would lead to a deadlock. So it is possible to have deadlock when all the 5 processes acquire 1 wait operation on the semaphore each. So option D is also true. So we got A, B and D as our answer.